Hi, my name is Wafiqah Zubair, and I am a student from Harmony Science Academy, ULIS. And this video is about my PBL project, a novel and enhanced approach to spacecraft and aircraft launching systems. In our modern society, current approaches to launching a spacecraft, aircraft, and supply carrier are varied and have negative consequences. When it comes to the environment, space vehicles release gases, dust, spacecraft detachments, and other substances into the upper stratosphere during re-entry. This contributes to ozone depletion and global climate change. The second disadvantage is launch systems are not fail-safe. Relating to my social studies connection, 5 space missions have failed historically that have resulted in the deaths of 18 astronauts. According to my ELA component, on October 11, 2018, the Soyuz did not make it out to space due to failure in the first and second stage rockets. Moreover, reusability has not been fully implemented in space launch today. Cost is another important drawback. The space shuttle system cost $1.5 million per launch. Rocket engines have their own supply of oxygen and fuel, which goes into a combustion chamber to combust to provide the rocket energy for thrust. Non-rocket launch systems are only used for partial launch. These include air-breathing jet engines, skyhooks, rocket sled launch, and air launch. My engineering goal is to create a more environment-friendly, fail-safe, reusable, and cheaper launching system to supply space settlements, launch satellites, and project aircraft. My design requirements restate my goals in designing a new launch system. After brainstorming, I came up with 4 ideas: the vacuum claw, the lever mechanism, the catapult mechanism, and the pulley system. I used a design matrix to find my best solution, the catapult mechanism, which consists of a piston and a cylindrical vacuum chamber with airtight doors. When the locked piston is released, it will shoot up at high speed due to difference in air pressure. Here is my prototype sketch. These are the materials I used to build my prototype. First, I cut a 2 cm wide plastic pipe to 26 cm of length. Second, I hot glue gunned 2 wooden dowels to create a 26 cm long piston. Then, I traced and cut out 2.5-inch circles from plastic cups. I hot glued them together, then to the piston. Fourth, I poked a hole through the cardboard piece and hot glue gunned the cardboard to one end of the pipe. After, I slipped the piston into the pipe and into the hole in the cardboard. Lastly, I rested the marble capsule on top of the piston. After building it, I tested the usability, performance, and durability of my prototype. I extracted all the air in the pipe using a reversible electric air pump and then released the piston. Here is my data table with all 30 trials. This graph shows all 3 measurements. Blue is usability, red is performance, and yellow is durability. As the pie chart shows, my prototype launched about 57% of the time. However, it never reached its goal height of 461 centimeters, failing in performance. For durability, it never broke during any of the trials. Therefore, my catapult mechanism succeeded in the basic concept but did not fully achieve its goal. In conclusion, I have partially achieved my engineering goal. My design is environment-friendly, reusable, and cheap. The mechanism is fail-safe based on the math, but my prototype was not. Space exploration is rapidly evolving, and space launch is the gateway to exploration. My design could be applied in real life for a variety of purposes. It can constantly supply space settlements cheaply, for instance. Then, funding can be directed to other NASA projects. Given this, if I were to build another prototype, I would try to implement the extra holes at the bottom or other propellants to increase the launch's force, and I would try to work out the failsafe condition. After doing this project, I would like to find out if there is a potentially usable way to turn trash into fuel for combustion so that rockets can be powered in a cheaper and more environment-friendly condition. Thank you for watching Harmony Public Schools.